Question 46 says solve each inequality, represent the solution on a number line. So it's probably time that we have a conversation about some shortcuts for solving inequalities. And I think I want to start by talking about at least this one. Let's consider the following. It is a true statement that 3 is less than 7, right? That's undeniably true. I don't think that's controversy at all. If you've got 3 and someone has 7, the person with 7 has more, you have less. 3 is less than 7. Now, if I was to multiply both sides of this inequality by the number 2, or I'm sorry, by negative 2, I want you to observe what happens. Multiply by negative 2. Over on the left-hand side, if I multiply 3 by negative 2, it's going to become the number negative 6. On the other side, when I multiply by negative 2, it's going to become negative 14. Now, you may have noticed which one is smaller now. Which one's smaller now? And I think fundamentally we have an idea, but you might want to consider a number line. Here's the number 7, and over here is the number 3. Over here is the number negative 6, and way over here is the number negative 14. So we know as we move to the left on the number line, right, things get increasingly smaller. So if I've got a comparison between negative 6 and negative 14, I would say that negative 14, right, is less than negative 6. But if I'm talking about negative 6 first, I would say negative 6 is greater than negative 14, right? The larger value is negative 6. Fundamentally, that happens every single time we multiply inequality by a negative number, or if we were to divide both sides of an inequality by a negative number. So you could also equally consider, let's look at the number 8. 8 is less than 12. That is true. If I divide both sides by negative 2, so I'm going to divide both sides of the inequality by negative 2, the left-hand side is going to become negative 4. The right-hand side is going to become negative 6. The question is, which one's larger now, right? Which one's larger now? Before, 8 was less than 12, but now negative 4, it turns out, is greater than negative 6. So if we're careful, and that's a big if, right? We may not always need to be locked into this really good habit of finding the boundary point, determining the type of boundary point, is it filled in or solid, but then also testing above or below. I still recommend testing. If you think there's any possibility that you could have made a mistake, the best thing you could do, especially if the number 0 is available, is plug in 0 and test that. But probably from this time on, I'm going to be solving more and more inequalities by treating them almost like equations, except I'm going to be very, very cognizant of the fact that if I am multiplying by a negative number or dividing by a negative number, I've got to make sure that if my inequality was less than, it's going to have to become greater than. And if the inequality was, well, it's just the direction of it's going to have to switch, right? It's going to have to flip around. And for all the reasons that we talked about here, right? So I hope that that doesn't seem like magic. I hope you understand that, yeah, when you multiply them like that, they literally flip, and the 7 flings way over to the other side and becomes a negative 14 on the number line. All right, so now let's come and take a look at these, and this should be pretty straightforward, right? The first one, I'm going to solve that inequality, and I'm just going to write 3x minus 2 is less than 10. And if you have things where, something's smaller than the other, and you add to both 2 to both sides, this is still going to be the case that 3x is going to be smaller than 12. And if I divide by positive 3, it's going to be the case that whatever x is, it's going to have to be less than the number 4. So on a number line, here's the number 0, and then here's the number 1, 2, 3, 4. The x's are those things that are not 4, but all of those things that are less than 4. So we start there and we go to the left, smaller than 4. Okay, so that's A. X's are less than 4, And you can see the direction of the inequality. Let's consider B, and I'll do B off to the side here. So same idea. I'm going to take a look at this, and I'm going to begin by combining the 5x and the negative 3x and just making 2x minus 1 is greater than or equal to 4x plus 5. I'm going to add a 1 to both sides, so 2x is greater than or equal to 4x, and then that's going to become a 6, plus 6, plus a 6. And again, I just added 1 to both sides of the inequality. Now I'm going to take away 4x from both sides. I'm going to subtract 4x from both sides. Not dividing, not multiplying. I'm subtracting 4x from both sides. When I do this, it becomes negative 2x is greater than or equal to 6. And then finally, what I'm going to do is divide. Oop, did you hear that? I'm dividing both sides not by just by a positive number, but by a negative number. So when I divide both sides of this by negative 2, this side does become x. This side becomes x. The other side becomes negative 3. And it is no longer the case that the thing on the left is greater than the thing on the right. It is now x is less than or equal to negative 3. On my number line, all right, I know that my boundary is not at 0, not at 1, not negative 2, but at negative 3. And the boundary is included, so I have a solid dot on negative 3. Negative 3 is a solution. And anything above that negative 3 would work, right? All those values to the right of it would work. And for example, if I was to plug in 0 into the original problem, this becomes, if I look real close, this becomes negative 1 is greater than or equal to, there's a problem here. I'm plugging in 0 to this. Negative 1, it is definitely not greater than or equal to 5. So I've got an issue. Let's see. I began by doing 5x minus 3x is 2x. Added 1, I got 6. Took away 4, I got negative 2x. Oh, I know what I did wrong. My inequality is correct, right? This is completely what I want it to be. This says x's are those things that are less than or equal to negative 3. I just happened to graph the wrong direction, right? I graphed those things above it. 0 does not work. So my solution's correct. My graph is terrible. So let's come in here and delete this. This says x should be those things that are smaller than, oh my goodness, smaller than negative 3. So if I was to plug in negative 4, it would satisfy. That's kind of nice because I did see, yeah, you picked a number off to the right, and it did not work. But as soon as you came back over and picked a number to the left, where you should have picked the number, it worked just great. So that's our solution and graph for B. I think I've got enough room to do D right in here. So I'm going to go ahead and, let's see, I'll distribute the 4 at the 4. So I'm going to have a 4x minus 12 plus 5 is greater than or equal to negative 7. That means that 4x minus 7 is greater than or equal to negative 7. If I add 7 to both sides, that gives me 4x is greater than or equal to 0. And if I divide both sides by 4, positive 4, I get that x's are those things that are greater than or equal to 0. Tough case for testing, right? Because I can't test 0, the point I love testing. But that's okay. We can still run a little test. So that's my solution. I'm going to quickly sketch a number line here. We're going to have a closed boundary. The closed boundary is at 0, right? This is the number, x is 0. And then I just need to see, it should be all those things above it, right? So if I plug in a 1, it should work. If I plug in negative 1, it should fail. Let's plug in the 1. If I plug 1 in here, this is going to become 4 times 1 minus 3 plus 5. 1 minus 3 is negative 2 times 4 is negative 8 plus 5 is negative 3. And on the other side, I got negative 7. So yes, negative 3 is larger than negative 7. It's not 7. It's clearly a negative 7. So the positive 1 side was a solution, so we're going to shade everything to the right. All of these points are solutions. The ones off to the left are not. In fact, if I was to plug that one of that point into the left, let's just plug in negative 1. This is going to become 4. It's going to become a negative 1 minus 3, which is negative 4. Negative 4 times 4 is negative 16. Negative 16. And negative 16 plus 5 is negative 11. And you know what? Negative 11 is not, that is not true. Negative 11 is not greater than negative 7, right? Negative 11 is smaller. So definitely we're shading off to the right. All right, the last one we'll look at is tucked away here at C. And that inequality, I'm going to distribute the 2 first. 2x plus 4. And then that's going to be greater than 10 minus x. I'm just going to take away 4 from both sides. So 2x is greater than 6 minus x. Add an x to each side. 3x is greater than 6. Divide by a 3. X's are greater than 2. So on our number line, here's the number 0. Here's 1. Here's 2. And this is an open boundary point because it was just strictly greater than. And it says that x should be all those things that are more than the number 2. More than the number 2. So all these things off to the right. Now, if I was to plug in 0, 0 should not work, right? 0 should be a failure. So it's kind of a quick partial check. I'm just going to come out and I'm going to plug 0 in there. 0 plus 2, 0. And then 0 times and then 2 times 2 is 4. And then on the other side, I've got 4 is greater than, let's see, 10 minus 0 is still 10. So, uh-oh. Oh, yeah, I was expecting it to not work, right? That's the side on the side, the non-working side. 0 doesn't work. If I pick anything to the right, it will work. So there we go. That's a different way of looking at these inequalities now. Be careful. You can see some of the pitfalls and you can see the mistakes I made. But I think it should speed our work up a bit.